Afternoon, everybody, and welcome back. We'll move on to our next session and the last session for today. Going to be a panel discussion on innovations and technologies for ESG in the power sector. We have Mr. Unaise Urfi, session keynote and moderator, starting off this session with his presentation and valuable inputs. But before that, a few words about him as I welcome him. Good afternoon, Mr. Urfi. Thank you for joining us. Currently a director at KPMG India, he is an experienced professional dedicated to helping organizations achieve transformation and growth through the synergy of people and technology. With over 18 years of global advisory experience spanning various sectors, he has a proven track record of developing and implementing successful strategies, particularly in the energy and sustainability tech domains. His core competencies encompass ESG, digital transformation, consulting, project management, strategy, and data analytics. Mr. Urfi leverages these skills to deliver innovative solutions that drive sustainability and digital advancements for clients, including net zero and decarbonization strategies, energy efficiency enhancements, digital strategy and transformation, digital maturity assessment, and Industry 4.0 initiatives. He also specializes in optimizing cost, refining processes, and enhancing operating models. Passionate about contributing to a more sustainable world, Mr. Urfi eagerly embraces new challenges and opportunities to create meaningful and lasting impacts. I would now also like to invite our panelists who would be joining Mr. Urfi for this session. Please welcome Dr. Santanu Satapathy, Head Environment and Sustainability, Apraava Energy. Dr. Satapathy is an accomplished environmental and sustainability expert with over 2 decades of experience in the power sector. His career has been dedicated to driving sustainability-focused innovation, energy transition, environmental and social impact assessment, integrated water management, air quality, waste circularity, biodiversity management, and fly ash management, among other areas. He excels in assessing ESG, that is environment, social, and governance risk, formulating decarbonization strategies, identifying strategic business opportunities, and implementing sustainable practices in both technical and non-technical domains. Dr. Satapathy is also a trusted advisor on policy and regulations in the sustainability realm. His expertise was recognized through his nomination for the prestigious Sustainability Leadership Program 2019, conducted by WBCSD Switzerland and Yale University, USA. Moving on next, please welcome Mr. Rajan Varshney, DGM New Initiatives, NTPC Delhi. Mr. Varshney is presently heading new initiatives at NTPC, the largest power company which is diversifying into related fields. He has over 35 years of experience in the energy sector. He has installed an innovative wastewater treatment system in NTPC corporate office. He took initiatives in ash utilization. He has designed and implemented the ERP system in NTPC in the late 90s and carried out many innovations that have won many accolades. He spearheaded the efforts for September 2020 notifications for H2HCNG as permitted fuel in Indian Motor Vehicle Act and safety standards for FCEVs. He is passionate about environment and sustainability. He has been lead speaker at various national and international conferences. His interest includes concentrated solar power, concentrated solar thermal, OTEC non-materials, wastewater, nanomaterials, wastewater treatment, CO2 capture and utilization, hydrogen economy, waste and biohydrogen, and sustainable fuels, etc. And we have Mr. Kaushal Vaishnav, who will join us as a speaker for this session and will be presenting his views on embracing circular economy principles for sustainable resources and management. Mr. Kaushal would make his presentation at the end of the discussion, and we would have Mr. Urfi make his session keynote, followed by his open discussion with Dr. Satapathy and Mr. Varshney, and then followed by Mr. Vaishnav's circular economy presentation. With that, over to you, Mr. Urfi. I will give you the access so that you're able to. Okay, do I share the presentation for you from my end?
Yes, please, if you can.
Yes, I will do.
Thank you, Shreyal. And thank you, and a good day to everyone, my fellow panelists. And well,
I hope the screen is visible.
Yes, it is. Thank you. Really appreciate it. That was a fantastic introduction, Shreyal. I think it was very flattering. uh, you made it sound as if I'm a PhD, which I'm not, and Dr. Satapathy is. But anyhow, thank you so much for joining us. I mean, this is quite an interesting topic, I must say, in power sector. And coming from a consulting background, I do work with a considerable amount of power companies in past and present. I have done, and while power sector at one. I mean, still kind of generates a lot of carbon emissions, but they have been steadily reducing over a period of time. And that is something that I would like to touch upon when I go to the next few slides. So, and uh, to my fellow panelists, please feel free to jump in wherever you think a discussion is required. We can use this deck as a catalyst for a larger discussion. So it doesn't have to go in any particular flow. Let's move to the next slide, please. So as you would see, as I said earlier, that the power sector is responsible for a considerable amount of global emission. And this is just not India, this is globally overall. While these emissions have sort of, and the data is right in front of you, so I will not read it out. But while this has considerably been reducing over a period of time especially in the last 5 years or so, and COVID kind of helped us realize that what we are missing when it comes to while we have been sort of involved in a race for industrialization, what we have been missing is the good climate. And I still remember during that lockdown period in COVID, the skies in Delhi were clearer. There were less people coughing around. I mean, it was as if my childhood had come back, and that kind of acted as a trigger, at least for me, to figure out how we can make our day-to-day lives a little more sustainable. I have tried to do it, and most of the people that I've been talking to, most of my clients that I have been talking to since COVID times, they have been trying to move towards a low-cost gas or a renewable source of energy, and which is something these charts will also tell you, that historically the emissions have been higher. I mean, the data says about 23% of the global emissions, but they have been considerably reducing. I mean, some of the countries in European Union, especially people in countries like Netherlands and all, have been doing some groundbreaking work across board for these on clean energy, especially. And I must say, India is not very far behind. The amount of government initiatives that have been put across for solar cells and to reduce emissions and for wind energy have been phenomenal. So moving to the next one, please. If you feel free to add something, Dr. Satapathy or Mr. Varshney, please feel free to do that. I mean, I'm happy to have a discussion around
Sure.
Yeah. So where do we see challenges in power sector is something, and this is purely from an experience perspective. I apologize for the overlap; it shouldn't be coming, but I guess it happens sometimes in Zoom. The power industry does face a lot of challenges, especially when it comes to operationally making a more climate conscious decision across. Whether it's related to your operations or its waste management, or trying to make your power grids much more efficient. And I must say, some of the power grids that have been made are digitally more efficient put across. I mean, one of the biggest examples which I saw in Africa. I work for one of the largest telecom operators in Africa, and one of the best examples of a private sector operator, a telecom operator, coming together with a power energy company was when we were doing their net zero strategy. And decarbonization strategy was when, as you know, in a telecom operator, there are various sites, and these sites have a tendency to generate a lot of energy and emissions across a lot of wastage, and some of these countries in Africa have civil wars going on. So what happens is you have to have a generator over there, and those generators have to be supplied with diesels or petrol. and mostly it's diesel, so bad fuel, and so that those uh, sites can be operational at any point of time. Now these sites have a 4 or 5 radio waves going through it, whether it's 2G, 3G, 4G, or 5G, or LTE for that matter, and the regular radio waves which are going through. Now what happens is, as more and more radio waves go through, as more and more traffic goes through, more and more power and energy is consumed over a period of time. So what we did was we basically tried to implement automated sensors over there, and these sensors helped us stop from a remote location when a particular wave the traffic was down. For example, if it's from 1 a.m. to 2 a.m. and 3G was not getting used in, say, DC in Congo, then you could automatically shut it down and reduce the power. Now, this solution was only possible because the telecom operator worked with the power sector, and it was a response to not only their energy consumption and savings need, but also a response to the safety security aspect of it. So we covered security, we covered cost optimization, and we covered environmental friendly energy. They saved a lot of money on diesel, and a lot of safety and security was taken care of as well. And a lot less energy wastage. Because the oil tanker does not have to drive from 50 kilometers away to fill the generator at a point of time. So, but this is just one very large and very open example of it. But of course, fall detection and response is something that improves your efficiency everywhere. From moving from digital grids to detecting faults before they appear, in terms of uh, the challenges and the downtime that you get on your grids is extremely important over there. So this helps you reduce a lot of carbon emissions across roads and helps you, cause less disruption around it. So while I move to the next one, and any thoughts over here to my fellow panelists, anything that you would like to add?
Yeah, I'm Rajan Varshney from NTPC. Whatever thoughts I'm giving here or ideas giving here are completely from my side and not to be linked with companies' perspective.
We understand.
Yeah. So in this now with towers, there is a facility that with respect to diesel type of things, there is now hydrogen also there, and hydrogen in the form of methanol is also there. So once you fill it and it runs for year, at least 1 year, 2 years together. So such facilities are also now developed even in India.
Yes,
So
absolutely. You're absolutely right. I mean, I do work with NTPC, and I know the amount of investment you guys are doing into safe fuels is phenomenally high, and you're trying to make the grids a lot more efficient. I completely agree with that. Mr. Satapathy, would you like to add anything to this?
Yeah, this is quite good example that you have cited, that how companies, for example telecom, so when they're trying to go for net zero or decarbonize their sector, so how they are influencing the power sector, so from where they are taking power, and that actually is a very good example. Power sector sometimes themselves are trying to add their prospects into global transition, energy transition, but actually when the demand like this comes, it makes them easier, and also it makes the uh, policies also easier in their favor. So I'd like to add this comment that this is a very good example that not only how the power sector itself is trying to decarbonize themselves, but also the pull and push from various spaces or various spheres are actually helping them, I should say, to make their transition easier. Of course the challenges are there in the transition, but at least the cause is getting more fuel to make it faster.
Absolutely. I mean, the more uh, the let's just say more value of money which we get from each liter of fuel or each liter of gas is what needs to be looked at, and that's where operational efficiency kind of will come in, because fuel has to be treated as your as an asset more than anything else. So you're
Absolutely.
absolutely right. So these kind of automation and technology interventions absolutely come through. Now, when we are talking about technology interventions, one of the topics that we wanted to discuss over here was, the role of digitization and smart technologies in enhancing ESG performance. So I would like to throw this floor open while we are on this slide to Mr. Varshney and Dr. Satapathy, that what do you think technology, what kind of role does technology play, and what kind of help that digitization has uh, helped improve the power companies' ESG performance?
Okay, Kaushal, would you like to go first?
Mr. Varshney?
Yeah.
Yeah,
Uh,
I'll come in slightly later. Just I have a call for one.
Okay, so
Okay.
no problem. So yeah, so I mean, Dr. Satapathy, the robotic process automation and all of these digital initiatives have kind of helped power companies kind of move to a more automated compliance and monitoring systems, right? So I'm sure in your experience you would have seen some of the work that you do with Apraava Energy. I mean, you are also at the forefront of technology innovation. So what has your experience been when it comes to technology interventions for ESG?
Yeah, absolutely. Actually, when you have thrown this question on the digital related, so I'll respond to this, and also maybe I'll take some time later to discuss on the fundamentals of even not only the CO2, that is of course the main culprit, but the other pollutants like SOx, NOx, and also water. How actually the technology intervention is much needed to reduce those, and what is the scenario in India, and what the sector is doing in that front.
We
Coming
can cover that in the next slide because that
Yes.
covers that topic, yeah, on that front.
Yeah. So coming to this is a very good area, and I should say that there are two things. One is how the robotic or digitization can help not only means in the data management and then better forecasting, but also simply I should say in our one of our 100 megawatt solar plant, actually how the robotic technology is going to help us to reduce the water consumption towards more than 85%. And when actually the solar plants have been set maybe 5 years back at the very initial stage, we're hardly thinking of the robotic cleaning of the panels, because we are more focused on first installing the panels, then producing energy. So those are very nascent stage, so few plants were getting installed. But now actually it is more the sense that most of the power plants which are coming, mostly though they will be coming with robotic technologies for the cleaning of the panels at least. And also when we have the older thermal power plant, older sorry solar plants, we are making some trial tests so that they also can be means equipped with robotic cleaning. So and Apraava Energy, I should say, is planning to convert all its solar power plants in instead of wet cleaning to robotic cleaning next 1 to 2 years, not very far. So that's why the technology intervention is very important, not only in the power generation, transmission, distribution, but also simply by reducing the water consumption, because solar plants you see are mostly located in water scarce areas, and where the cultivation is not that good due to scarcity of rain or scarcity of groundwater. So then it comes when we are putting big solar plants, then we are consuming the water, groundwater or the surface water nearby, so making it less available to the community nearby. So that is actually where the technology comes into rescue, and at least 85% is not small quantity, where if you're putting a robotic cleaning of panels. That is one. And second is, I should say that the central monitoring facility that is actually we have implemented at Apraava Energy, where actually all our solar and wind uh, assets are being monitored through a central monitoring, real-time based monitoring facility, which helps us to identify any future uh, problems we are going to face, or even better forecasting of our generation, and also helps to facilitate data from various OEM equipments being brought into a single platform, which enables easier real-time monitoring of wind and solar asset, and continuity of data helps to analyze and avoid operational challenges and improve output. So the central monitoring facility, actually it was implemented 2 to 3 years back at Apraava, actually, where around more than 20-25 sites are being monitored on a real time at the control room here at the head office. Actually, that actually is helping us to avoid or improve our uh, operation maintenance activities, and also second is better forecasting of our generation. So these two I'd like to mention here immediately. And of course the third one is not exactly related to power generation, but the data and information management. Actually there are uh, various ESG softwares which are coming into picture now, and when we are going to evaluate, so that there are various options available, so that we can, which will help to manage the ESG data in a better way, then analyze it, and also forecast your targets in each areas. For example, in water or waste, or even in the carbon. So these are the softwares. Actually, I think KPMG may be having similar software. I am not
You're right.
sure,
Yes.
which is being provided to various
Correct.
power operators. So that
Hmm.
also is another technology uh, related aspect, which most of the companies are now opting for, to
Correct.
manage their ESG data, and also not only manage but also to disclose their ESG performance.
Absolutely. I don't know whether Mr. Varshney is back or not. I don't think Mr. Varshney is back. So, anyways, we'll come back to Mr. Varshney when he joins back the um, joins back the conference. Now, moving on to the next slide, please.
Yeah, because in the, sorry, just to and I could see a couple of few bullets in your previous slide. So there's a lot of intervention, because when you are interacting with various ESG providers, solution providers, so the supply chain, that was, I could see in the last bullet point, the
Yes.
supply chain sustainability related softwares actually gaining good pace. Not only pace, but not only just to provide uh, the information on various ESG fronts, but also
Mm.
how we can calculate the scope 3 using those supply chains software, so that through it will reduce the manual intervention, and through by sending a simple link to the suppliers, if they feed in their information, how we can have the scope 3 emissions quantified.
Yep.
So that we are trying with various vendors. Of course we have not come to a conclusion or a better solution, but that is a question to the panel, or a means a topic to the panel for discussion, if anybody has
Absolutely,
any
completely agree. I mean, and that's why we moved to this slide, because you were talking about some of the low carbon measures and the use cases that you and your organization have been working on. And the reason I did not pick supply chain over here, but I decided to pick supply chain over here because supply chain is an excellent use case for blockchain as well.
Yeah.
And that's why I thought we'll discuss it over here. But now that you picked it up, so coming to your initial point on how carbon, how it, how important it is to become carbon neutral, and in your organization, have you come across a use case on carbon capture as yet, or not? I mean, or is it still in research phase?
Yeah, that is actually, I should say, in in the
Yeah.
power sector and clean technology adoption. When we say, if we
Mhm.
discuss about all the things what we are doing and what are not doing, what we could able to
Mm.
adopt, like a flue gas desulfurization unit, that is of course is one of the very advanced technologies to reduce sulfur dioxide emission around 80 to 85%. And we are
Mm.
the among very few, at least 3 or 4 power plants in India, power units, I should say, out of 600 units. Uh, we are among the 5 or 6 units who have implemented the FZD back into the 2012, when there was no requirement of compliance requirement to reduce SOx emission, and the compliance requirement that later came in 2015, and that is to be complied by 2017. So when there are 600 plus units in India thermal power plants running, and as on date, even the compliance requirement came in 2015, till now only 6 units are complied, and
Mm.
out of 6, Apraava is having 2 units, and rest 4 or 5 units are still not complete in operation. There are challenges. So actually, to coming to your question immediately, there are various adoptions happening in the power sector to reduce pollution. But when you are asking about the carbon capture, that I should say the biggest challenge in this technology for adoption. And I, along with my group colleagues from CLP Hong Kong, we have tried and discussed this technology with various solution providers in Canada, in UK, and the challenges are, of course, cost, and also the quantity of carbon dioxide which is being emitted for a thermal power plant like our size of 1320 megawatt. So that is actually, it is not a means a small thing. It requires a lot of capital investment, and the largest one that is available in the world is around 400 tons and per day, carbon capture. And if our thermal power plant, which is around 1320 megawatt, if it runs even a 50% plant load factor, it generates around 6,000 kilotons in a year, which is coming around 15,000 tons per day. So when there is a highest size is only 400 tons, so there is a lot of speculations that how means it can be implemented and will be successful, irrespective of the capital cost involved. And there may be solutions may come from the policy. If the policy drives the implementation, there could be more interest from the power sector. And one is carbon capture and storage, and one is carbon capture and utilization. So if the utilization sources can be enhanced, so there will be opportunity to get even the return on the capital investment. So these are the challenges, I should say. So that's why we have not further explored it. These are the challenges for us. And also we tried to explore one more option, is that we have the fly ash. Thermal power plant are having the fly ash generated, and the carbon can be CO2 generated from the site, can be directly injected into the fly ash, making them ready to use concrete instead of cement. So that is also trial being taken in Canada and useful. But the challenge we are facing in that is, once we have this CO2 injected fly ash, but the off-taker, the cement, the construction industry, are they ready to take this as a replacement to cement? So we asked those solution providers to discuss this with the construction industry, or even the, I mean, it's a government level, whether this can be off taken once it is produced at the site. So that they are working on still. So this actually, these are the few thoughts which is coming immediately to my mind on the carbon capture and storage, and these are mostly the challenges.
Absolutely. No, I completely agree with you. You are absolutely right. I think Mr. Varshney is back with us. Hello, sir. Are we audible? Can you hear us?
Yes, yes. I am here.
I think you are on two
Some
speakers.
problem is again there with the video. Yeah.
Okay, no problem. Sir,
Okay.
I think you are logged in from two devices and there is an echo coming. Can you mute one of the device?
One of them is muted only. Okay, okay.
All right. Okay. All right. So the question that we wanted to come to you was in the previous slide was during the role that digitalization and technology plays in transmission and distribution is something that your experience kind of we wanted to see what kind of use cases have you seen, what your experience has been about technology interventions in transmission and distribution.
Yes.
Sir,
Just
again,
just a second. Just a second. Let me leave from one. Yeah. Now I think it will be better.
yes, sir. This is definitely better. Please.
Okay. Actually, digitalization has improved many efficiencies, and it has made many things possible which were earlier not possible. So, with lesser energy consumption and more automation, the things have improved a lot. Like now, since last 10 years, you may not have seen any instance where grid has blacked out. So this has been because of our interconnection of various grids, regional grids, interconnection, and moreover control over dispatch load. So this is the advantage of this digitalization and faster communication, which has come with the 4G and 5G now. So
Okay.
this is my point. Yeah.
Sir, when NTPC sort of decides to go ahead and do investments in technology in new age and technologies, what role does sustainability or ESG plays when you're doing this investment? Is it discussed in the boards? And before you taking the decision, is NTPC consciously trying to become carbon neutral soon?
Yes, definitely. We try to take whatever steps are technically feasible, may not be financially feasible, as pilots, and try to explore the technologies available and even support some of the technologies which can develop at scale. So, being public sector, we undertake the responsibility to be first mover in newer technologies, and then rest also follow it. It's not that only NTPC does it, but in our thinking or in our ESG responsibility as a responsible corporate citizen, we try to do it.
All right, sir. Thank you for that. I also realize that NTPC is also trying to distribute a lot more clean and renewable power over the period of time. They have increased their share on that. Um, uh, uh, would you like to throw some light around that?
Yeah,
Because this is,
we have set a target of 60 gigawatt renewable capacity by 2032, and we are doing it even faster than that. We may be able to achieve it much earlier. So this is increasing our greener content. Then we are going into EV buses and hydrogen buses. Then biofuels like methanol, ethanol, hydrogen, we are going in a big way. So these are all hydrogen is something like it is. We should not consider electricity as only the energy, since it is only 18% part of the total energy consumed. So like hydrogen is such a versatile thing, it can be converted into electricity also, and can be made from energy or electricity which sometimes is getting curtailed. So one way this is like cutting across various sectors in energy. Then second, hydrogen is a feedstock to many industries and in many processes. And third, it acts as a fuel also. Part of energy, but may not be directly electricity. It can be through ICE engines also. So it replaces our import content of say oil, petrol, gas, etc. And in some cases, it reduces our import content for coal also, like for steel plants or aluminium plants or glass things. We can use hydrogen also in the furnaces, and say for in alumina electrolysis, we can use hydrogen energy produced through hydrogen and such things. So we are like entering into so many things that NTPC name may be sometimes changed to National Transport Power Chemicals Limited. All these are with the eye towards net zero and sustainability. Right.
Absolutely, sir. I mean, you are leading the way. Dr. Satapathy, don't you think that ESG and sustainability is an excellent use case for public-private partnerships to run through to improve our, to take us closer to our targets of net zero and decarbonization? Sir, you're on mute.
Yeah, absolutely. And as mentioned by Mr. Ranjan, that NTPC is going to add 60 gigawatt of renewable energy by 2032. So that says the volume and the aspiration of a public sector company. And you see, like Apraava Energy is, of course, very, very tiny compared to NTPC. And of course, our investors are quite big, having presence in Asia Pacific region, and mostly operating and generating and supplying 80-90% electricity to the city of Hong Kong, and presence in Australia and China. And of course, in India, Apraava Energy is having around 2,500 megawatt of electricity generation capacity, and 47% is renewable energy, and having one thermal power plant that is based at Jhajjar, Haryana. And if you see I was just looking at the National Electricity Plan 2022-2032. Our thermal power, while we are going to add renewable energy in a big way, at the same time, the thermal power plant, thermal energy is going to be there till 2050 even. And what the national plan says that by 2032, our thermal power generation will increase by 52 gigawatt. And also the Bloomberg NFL says that another 50 gigawatt will be added by 2050. So existing is already, we have 235 gigawatt, and we are going to add at least another 50 gigawatt by 2050. So that's why actually the challenge is, and current our electricity generation from thermal power is 75% generation, I'm telling, not the installation capacity. And 2032 it will be around 50-60% still. So that's why while you are going to decarbonize through renewable energy or hydrogen, it is also very important how we can make the thermal power plant more cleaner, so that it will not be looked at completely a dirty power or the polluting power. So that's why I can cite the example of our thermal power plant based at Jhajjar, Haryana, which is 1320 megawatt. And the features, first of all, it is a supercritical thermal power plant. Of course, now it is mandatory to put supercritical, but when we put the thermal power plant in 2012, it became operational. At that time also, without any requirement, it was a supercritical, which is at least 1.5 to 2% more efficient. That's by reducing the CO2 and all other emissions and resource uses. That is one. Second, as I was mentioning your previous question, that it is equipped with flue gas desulfurization unit without the compliance requirement, and the cost of FGD, at that time in 2012, it was 400 crores. 400 crores, which has been put by our investors requirement or investors uh, focus, that wherever we put our plants, irrespective of the legal compliance, we should adopt the best available technology at that point of time. Of course, the legal requirements came in 2015, or now still it is hardly any thermal power plant are complying in Delhi NCR region. And as I mentioned, only 4 or 5 plants are complied in all over India. That is second. And the sulfur dioxide through FGD is reduced by 85%. So that is not a small thing. And next, again, in the thermal power plant, I'm telling the features which can be adopted to make it more cleaner. Third is low NOx burner. So which now mandates not only the no low NOx burners, but to reduce it further by catalytic reduction. So for the new thermal power plant, but at least we have the low NOx burner, which is at least 50% more efficient than others. Third is the particulate emission. Mostly thermal power plants having the electrostatic precipitator (ESPs), but this thermal power plant is equipped with ESP as well as bag filters, which further reduces another 50% of particulate matter emission. So these are the features. And fourth is, I should say, the water consumption. So it is one of the best in the country. I can say less than 2 meter cube per megawatt hour, in spite operating with FGD, because FGD also consumes a quite a good amount of water. It is in addition to zero liquid discharge, it is consuming less than 2 liter per unit, or 2 meter cube per megawatt hour. So and the ash disposal, again, actually we are able to dispose 100% of our ash generated at the site since last more than 5 years. So while we are operating a coal based power plant, and a energy company like Apraava is going to decarbonize itself through only investing in renewable energy, wind, solar, and also we entered currently into power transmission business, having around 450 kilometers of transmission lines. And recently we entered into smart metering as well. So you are also mentioning about digitization. So Apraava just entered into power smart metering, having won 2 or 3 bids in Assam and Gujarat to install at least 10 to 15 lakhs of smart meters. So those also will enhance the means power leakages, and help the consumers to get better service, and also the discom, or the power sellers to measure the actual power is sold, and also get the revenue generated in a more efficient way. So I just trying to mention that even if we are operating the thermal power plants, how we can make it more cleaner, because we are going to have not only the current generation capacity, but we'll be adding another 50 gigawatt by 2050. So these are the clean technology features for the thermal power plant, which must be adopted for in future, and where possible can be retrofitted in the current thermal power plants across the country.
Thank you, Dr. Santanu, for elaborating the features. But I have a different opinion, not on how to make these plants efficient, but how to reduce their number, or whatever you are burning, it is coal only and it is generating CO2. So, and as we are increasing our renewable capacity, or the part of the renewable like PV, it is generating during the day and the power is inform. So we should, I am trying for last some years to install CSP plants, concentrating solar power plants with
Yeah.
storage, molten salt storage,
Okay.
and they can work as a base load plant much better than coal. And of late, the cost of capex per megawatt of coal-based thermal plant as well as CSP with storage has nearly converged. New power plant coal-based with the FGD and these NOx, SOx and other ash utilization features comes at around 10 to 11 crore per megawatt. And again, we have to feed in coal, we have to cut jungles, mine coal, spend energy in coal, transportation to power plants, establish railway network, establish wagons, establish all the things. And
Yeah.
we are like generating electricity at 30% efficiency and using that electricity in transporting that coal also, and then burning it, and then trying to reduce those things like ash and particulate matter and SOx and NOx. So if we have these plants like CSP with storage, we don't have to burn coal. We can use directly the solar energy. And uh, the life of this plant is hardly, coal-based plant is 25 to 35 years. And that too,
Yes.
in between, we have to do certain modifications. Overhaulings have to be done regularly. Uh, Yearly maintenance have to be done. Preventive maintenance have to be done. In CSP plants with storage, we have a cycle of say around predicted life of around 75 to 80 years. Because glass doesn't, it's quite inert, it doesn't react with anything. And the molten salt also, which is used for storage, remains as molten
Mhm.
salt for any number of cycles and offers a long duration storage, which is thermal storage. We are not converting first to electricity, then converting it into some other form for storage, and then converting back to electricity. So our efficiency is also higher. Moreover, this electricity, since it is just like steam turbine based electricity, because boiler is there, but it is not burning coal. No furnace is there. It is a heat exchanger,
Yep.
which where the heat trapped in the molten salt gets exchanged with the water and steam is generated. Then rotating inertia is already there. So it helps in our ancillary services like maintaining frequency and voltage, the reactive power and other things. So we should have a joint effort maybe in all power sector, that instead of depending on coal as base load plant, if we go for this, it is cheaper also for end user also, because capex is nearly same, opex is nearly nil. And in coal based plant, we are spending a lot in uh, coal and other chemicals. So this is one point. Second point is because of this, we get firm renewable power 24 by 7, which can compensate infirmness of PV also. And if we keep on adding PV power, photovoltaic power, though people today understand solar as only PV, but that is why I am specifying clearly PV solar. Then what will happen is during the day, even presently also, all the coal-based power plants are to be run at technical minimum, because solar is available during the day for 3 4 hours at least. Our plants are just running at a very low load. But if you run at low load, whether you have supercritical or simple basic old plants, pollution level is higher for all of them, because the coal-based power plants are normally designed for an efficiency of efficient running at 85% or more load. So if you are running at 55%, you are not able to control anything, like whatever we have installed the facilities. And coal consumption also per unit electricity is higher. And these plants are not made to be like you run for 4 hours, then shut it down, then run for another 6 hours, then shut it down. So it is better to go for CSP with storage. And one more advantage of CSP with storage is that of our grid, 40% load is of cooling and heating, even industrial heating and industrial cooling also, and malls, big offices, hospitals which have cooling and heating load. So all this load, or maybe 10-15%, can be transferred to CST part of it, like thermal heat from the concentrating solar. So in this, what happens is our peak load and base load, they become convergent. Like today, peak load is 240 gigawatts, maybe for 1 minute in a year. But to meet that peak load, we are installing more coal-based capacity, and base load is hardly 180 gigawatt. So only 180 gigawatt continuously plants are running, and in the day the solar is there, and these plants are running at so-called base load plants are running at only very little load, or some are shut down. And then when the load requirement or to meet the peak, we are starting them. So in this case, if we transfer some of the load to the CST part, it is highly efficient also, and that peak itself gets reduced. Peak is not there, rather it is all uniform nearly. Then one more point is, by increasing efficiency, which was touched initially also, we can cut down our electricity requirement, and more capacity is maybe required, but for other things like carbon capture and converting to biofuels, and then for making hydrogen, making these ammonia and other things which we are importing. So all this can really help us in controlling our pollution as well as controlling our imports also. And one more aspect is there, which was shown in the first slide, waste to energy. So if we use our waste for various purposes, like we can convert waste into syngas. Syngas is the basic building block for various chemicals. So petroleum extraction is not required, or lesser imports are required for our country like India, which doesn't have those resources that much.
Those
Then
are
yeah.
those are some excellent points, sir. I mean, phenomenally good. And I know, Dr. Satapathy, you want to speak something, but we have only about 30 minutes left, and we need 10 minutes for Q&A as well. And we have a presentation with Mr. Vaishnav coming in. So
I'll just add two more points, and
sure.
these will make this all very informative. From waste, different types of wastes are available around the year. And some wastes are available seasonally, but if you use all the wastes, this will reduce our GHG emissions also. Like wet waste or agro waste, when starts decomposing, it releases methane automatically. So
correct.
instead of letting it released, if we use it, this is nothing but the gas imports which we do for energy.
Yes,
So
you're right.
these can be tapped in right in the beginning itself. And moreover, when they go to landfill site, there are blasts in the landfills because of this entrapped methane. So
Yes.
again, the air pollution when fire occurs and all. And the other landfill sites, like when rains happen and otherwise also at times, water gets polluted with the leachate. So to control air, water and soil pollution, we should concentrate on waste and produce energy things like biofuels and maybe from some part even electricity for 24/7. We should do it. And last thing is that from the waste, if we utilize landfill sites won't be required, and costly lands which are logged into this landfills like Gazipur land, it was estimated that it will be sold for 25,000 crores if it is cleared off.
Yes,
So
yes,
these are
yes,
the
yes.
things.
I remember.
And one more thing, the hydrogen from waste can be made even today at below $1 per kg. And this one example of improving efficiencies was like I have installed one STP in my office which doesn't use electricity for treatment. And present centralized, so-called centralized STPs waste lots of electricity, and moreover 80% of the total capex of the system goes into transmitting those sewage part into pumping and all this and laying pipes and all. So we can be cost effective if we use decentralized waste treatment. We will save electricity, and best part is we reuse that treated water locally, which is not possible in centralized remote located plants, because again lot of expenses is required to get the transmitted treated water back to the points where it can be reused. So it is not reused. So it is mixed with the fresh water, whether it is partly treated or whatever. Without testing it gets mixed, so it is again spoiling those things, fresh waters also.
Right,
So
sir.
these are my points which can help in overall ESG improvement. Uh, right.
Fantastic. Thank you so much. I mean, wow, some of these were real eye openers. Dr. Satapathy, last 2 minutes, you wanted to say something, any comments before we move to the presentation?
Yes, I'll not take much time because definitely I have so many points, and of course, Mr. Ranjanan throw further points for discussion. So definitely, I'll just keep it short and sweet with 1 to 2 minutes. Then, of course, the dialogue can continue among us. So definitely, actually, what solutions you have mentioned, Mr. Ranjan, that is very means absolutely right. Only thing is that keeping in view of the practical approach, actually, it is easier said than done. And we have, if you see the worldwide, what the UK is facing, why they are coming back to coal again. So these are still not the able that much developed to take the base load. So that's why the projections that the 50 gigawatt is going to be added, and that is going to be added definitely. So even if we have other technologies coming off slowly, and hydrogen and other technologies will come up, but the increasing energy demand, even the 500 gigawatt what our plan is by 2030, that is going to barely meet the increased demand. Forget about the base load. So maybe in long term, further towards after 2050, this will be much more reliable, and will able to take the base load. But at least next 15-20 years, I am telling that along with we are going for the renewable energy. You mentioned about the concentrated solar and hydrogen and all green ammonia, everything. But at the same time, we also need to make the coal more cleaner, because we have to live with coal for at least 20-25 years as a base load, or more than 50% of countries generation. So that is my point. And I always, as an environmentalist, always I like that all the coal power plants to be shut down means next year. But that is not possible, or that is not practically means also feasible. So that is my point. And of course, means let us hear about what Mr. Kaushal is presenting. Then actually, we can have the QA session. That
We
I
can
think
come
will be
back to
better.
this conversation and a
Yes.
larger discussion. So,
Yes.
what do you?
Urfi, I have to leave actually in 5 minutes. I just
Sure.
wanted to add one
Yes,
point
sir.
that
Yes,
this
sir.
is 500 gigawatt is nothing. It is a big number only, but
Exactly.
installed capacity is 500 gigawatt. But if
Yes.
we count the energy, it is running only for 6 hours a day. So
Yeah.
really, it is 125 gigawatt. It is nothing much.
Absolutely.
So,
Absolutely.
so
Absolutely.
if we have a CSP with solar, actually what happens is in India there is 330 days, 360 days sunshine available. But if we compare Canada and UK and other things, they don't have that much sunshine. So we have to adopt the technologies which are available for us to adopt, easily adoptable here and useful for us. And whatever points I have told you, these are all business models which are sustainable. In waste management, we can get back our capex in 3 years and then enjoy the returns, heavy returns in next 30 years. And
Absolutely.
and one more point, this CSP thing is like now in the last 3 years, more than 4 gigawatt capacity has been installed in the world across, and maybe in last 20 years it was hardly 3 gigawatts. So total capacity is 7 gigawatts installed capacity in world, and out of this 3 gigawatts or 2.5 gigawatts is installed in China itself in last 2 3 years, and in
Right, sir.
next 10 years they are installing more than 60 gigawatt of CSP. So at least we should not copy, but in this case we should be at the forefront to come up with the CSP fast.
Absolutely, sir. I mean, I'm a big believer in having best practices, whether it doesn't matter which country it's from, whether we have good relations with the country or not, it doesn't really matter. If there are certain best practices which help everyone, because at the end of the day, environment is not concentrated by boundaries, right? It's a boundaryless thing. Climate is boundaryless. What happens in Argentina can easily impact India and China both. So I am a big believer. You are absolutely right, sir, on that front. So over to you,
Mr. Urfi, we have
Vaishnav.
one question in the Q&A box. Would you
Sure.
want to
Yeah.
just take that?
Okay. If we have time, we can, Sheeta. No, not a problem.
Yeah,
And
maybe you can just take that one question and then we'll move to Mr. Vaishnav's presentation.
all right. So this question basically goes out to Dr. Satapathy and Mr. Varshney over here, that any percentage of hydrogen in gas turbine or any fuel in what is the percentage? I think that's what they wanted to write. What is the percentage of hydrogen in gas turbine or any fuel in thermal power plants?
Yeah,
So
actually, we are trying to get this hydrogen into our power plants, but because of present cost of hydrogen through electrolysis, because we want only green hydrogen to be used in our uh, gas turbines or burned with the co-fired with our coal, or ammonia also should be green ammonia. So we are like scaling up these technologies, or trying to install more capacities over 3 4 years. And in the meantime, the world has tested even 100% this hydrogen in gas turbines, or ammonia also in gas turbines. But whatever is being done is hardly 10 to 15%, or maximum 18% is getting mixed in the natural gas in gas turbines. And in coal based plants, some ammonia has been test fired only once or twice. But the systems are getting developed. Maybe in 4 5 years, the costs are coming down of hydrogen and ammonia. And then also coal will be maybe say 30 40% reduced in power generation. This is my point.
Dr. Satapathy,
Yeah.
would you like to add something to it?
Yes, actually, in addition to what Mr. Ranjan said, so I'd like to add that in our coal-based power plant, of course, we have only one coal-based power plant in India, and we are going to shut it down in 2037. So, and so maybe prior to its expiry, PP expiry. So, but actually, we are adding, as per the Ministry of Power's regulation, we are adding at least 1% of biomass in the coal as a co-firing. So that actually already been started, and we are trying to increase it to further 3 to 4%. Hydrogen, actually we are not currently opting for the co-firing, because we are planning rather more earlier closure of the plant, or maximum by 2037 its expiry date. And that is actually also reducing our emission, as we are co-firing the biomass which is available in the nearby region, particularly the crop residue. From the crop residue, we are eliminating some of the crop residue from burning, actually, which is one of the major pollution in Delhi. So green hydrogen, of course, is the option, not the blue hydrogen, or the uh, gray hydrogen. So that is actually we are not exploring as of now, because unlike NTPC, we don't have that much thermal power plants in our belt.
Ajay, you have added a very good point. This we are also doing in our plants this biomass co-firing,
Yes,
and
yes.
moreover at Vindhyachal we are having a pilot for carbon capture, and we are installing the bioethanol methanol facility right there, and in one other plant we are planning for installing bioethanol. So we will co-fire these fuels also along with coal. So again the coal intensity, carbon intensity will reduce.
Yes.
Thank you.
Thank you so much, sir. Now, if there are no further questions, Sheetal, should we move ahead?
Yes, you can move ahead.
Well, yeah, sorry. Okay, so over to you, Mr. Vaishnav.
Mr. Vaishnav, I've given you the access to share screen, so you could share your screen, please.
Yeah. So thank you so much, CE team, and thank you, Mr. Urfi, for inviting me here. And I'm glad to share screen with Dr. Santanu Satapathy sir, then Mr. Rajan Varshney sir, and all the key dignitaries from the power sector. So thank you so much for being here and providing this opportunity. Without taking much time, I will quickly go to my presentation. And the theme set up by the CE is the circular economy. So I will quickly present my screen and share. Just please let me know once it is visible to you all.
You need to go on the slideshow mode.
Hope it's in the full screen mode.
Yes, we can see.
Thank you. So the topic today is circular economy, and we all know that with ESG practices prevailing in today's world and market, we are moving towards use of better solutions and better ideas to enhance the efficiency, to find better use of the materials or the products we use. And on that line, basically, this concept of circular economy has taken place. And basically, the circular economy in energy system context is that it is energy circular economy in the energy system consists of designs, processes, and solutions that maximize the efficient use of natural resources for energy production, and use of energy, excess energy, and side streams. So by that means is that what it means is that at every aspect or every possibility, whichever we could tap for the better use of energy and minimize the wastages, that is what the basic idea of the circular economy is. And from the Saudi Aramco's perspective, what they define is that a circular carbon economy is a framework for managing the and reducing the emissions. It is a closed loop system involving 4 R's. What are these 4 R's? Reduce, reuse, recycle, and remove. So I will explain these 4 R framework which Saudi Aramco, a big giant in oil and gas market, has defined. So basically, it focuses on reducing the wastage of energy so that energy efficiency takes place. reuse of any byproducts or CO2 driven products, which could be utilized to either minimize the your pollution or pollutant kind of materials, which could be reused to basically give any better products. Then recycling of similar components for better process orientation, and removing the further waste which could be which is not really going to support us, then identifying the right methodologies to remove that waste. So briefly, we all are aware that earlier we used to take a linear economy in place. Like we used to take the product, make something out of it, use it, and then waste it. Then recycling economy took place, basically, which was that we were making take from in the step of take and make, we were and use. We basically were after using that product, we were recycling it. We were making some better products out of it or similar product out of it, and then again it was going into circulation, and then it was going to waste. In circular economy, we are kind of trying to find out uh, uh, new technologies or new systems or new processes which gives us more momentum in the cycle of make, use, and recycle. So that's the basic idea of the circular economy. Now, there are three key principles which basically supports us in adhering to circular economy part, which is design out waste and pollution, keep products and materials in use, and regenerate natural systems. So right now, this concept is basically taking shape, but to basically implement it further, we have to really think through a lot, and it will require extensive product and business process redesign. So our processes and understandings need to be redesigned to adapt this technology or the concept. And moving to the next one. So India on circular economy. So recently we had the G20 presidency, where India has mentioned key 4 points: that circularity in the steel sector, extended producer responsibility (EPR) as we call it, to be implemented, circular bioeconomy to be on is going to be our focus, and establishing an industry-led resource efficiency and circular economy industry coalition. So those coalitions and the efficiency related measures we have to take in picture, and that would be driving the further implementation of the CE. Quickly touching base on the type of waste, we all have read it. It is a very basic subject that, and we have gone through multiple times. So I will not put too much of time on this part. So definitely there are three categories of the waste: municipal solid waste (MSW) as we call it, which includes your household, commercial, or similar inert and hazardous waste. Then it is the second type is industrial solid and liquid waste, which is basically the waste from the food processing, packaging materials, glass, stone, ceramics, wood, cloth, solvents, resins, paints, and oils, etc. Third one is the agricultural waste and residue. So waste generated from the agricultural part of it, like crop burning, the wastage of the foods, the vegetables, and etc. So how circular economy and waste management goes together. So in that process, if you see the larger image where the treatment of this or the correlation between these two aspects has been shown. So basically, whenever we are having a resource, we go through the extraction, then the transformation of the product has to take place. And if we go by the linear process, then definitely it goes through the consumption and use. But then the recycle of waste or takes place in the recycle economy, and further in the circular economy, we have to further retreat or treat that recycled waste, and again find innovative ways to use that ahead. And once that is done, we have to we have to go through the elimination process, and then the final waste is accrued. So basically, the in terms of circular economy, the final waste which we are going to get would be minimum, rather than the straightforward line which we were following earlier. Now, how to accelerate the transition through circular economy, and what are those business models which we could look forward to? So there are 5 key pointers on these lines which we have to either implement or take a note of it. First of that is product life extension and reuse. So we have to think through the possibilities of maximizing the utilization rates. We have to achieve the optimal value out of the products, the energy we use or the resources we use, so that it could help in maximizing the lifespan of the product. Second is recycling of waste. We have to ensure that the lifetime of the product, if it cannot be used further, we could either look at the tiny part or the sub part of that material, so that this could be further either create a new product, or it could be subutilized into a already running product. So that way it could be helping in enhancing the life of a running product. So those kind of possibilities we have to explore by recycling the waste. Third is product as a service. So rather than just owning those product by masses or as an individual, we can look at the possibilities of product as a service, which includes that we, rather than creating it as a product or asset, we look at leasing it, we look at renting it, or we could kind of implement the pay per use concepts here, or schemes, which would help us to basically get more visibility in terms of the product utilization, and the new requirement for the same product is minimized. Fourth is sharing business models. That is again the same model in a way, but where we have to basically use it the larger scale in terms of the products and the ownership. Fifth one is the circular bio-based business models. So materials extracted from the virgin processes of the bio-based materials, basically in the renewables or even in the other materials, these products need to be reprocessed, or the basically process has to be reprocessed, so that it is fitting in the model of circular economy, and we are getting high value products out of those processes, and energy consumption is minimized. So when energy efficiency, the product efficiency is higher and the wastage is lower during the production processes, the circular economy is well implemented. So circular transition demands a lot of collaboration, partnerships, and increased coupling across the sectors. So to explain that, let's understand from that image that there are 4 circles in our society or in our business regions. That first is the business, then there is waste sector, then there are consumers, and then there is public framework, right? So public framework govern all the operations, the productions, and the similar processes. So this basic slide would kind of give an idea how these 4 parts would collaborate together, so that we are getting an optimum circular economy implementation. So from the public framework perspective, we need to create frameworks which are basically which are providing economic incentives for the development of sustainable and circular solutions. So the EPR which we mentioned, like extended producer responsibility, that is one such framework. Second is we have to secure an effective waste sector and classification of the roles. So right now, what happens? There are certain maximum times the classification of their responsibilities is not defined. So things are majorly left out, or the loopholes are there. Due to that, those processes or those ideas are not getting addressed, right, or not getting implemented. So to basically fill that gap, if we are defining the responsibilities, that would help to understand each and every stakeholder their role in the process, and accordingly, if everyone is doing their part right, the process will correct itself. And third is the obviously the green public procurement. Now from the business perspective, design circular products. So basically, when we are designing any of the product as businesses as a mass production, we have to look at the possibilities that if the design aspect of our product could be in such a way that these could be reused multiple times. If we could come up with certain design ideas which supports this fundamentals, then definitely it is a win-win for the circular economy prospect. Then implementation of circular business models and demand and use of bio-based and recycled materials, reduce CO2 obviously, and then sorting of waste at the company, or which we are right now doing also, that wet waste and other type of waste we are segregating at the source only. So those philosophies are to be implemented on the business side. Then waste sector. So this is a very critical chain between all these four parts of the slide, because waste sector is little disorganized in a way, and once that is where we have to basically keep on basically we have to work on the efficiencies of improving the waste sector, their roles, their responsibilities, their process and governance that need to take place little more effectively. It is going definitely. It is taking new measures, but again, from the circular economy implementation perspective, that has to be that has to grow at a little larger rate. So there, waste sector has to assume role of a link between consumption and production, develop the infrastructure and skills to reuse and recycle waste resources, transform waste resources into materials, and develop and maintain a high quality recycling and demonstrate transparent resource flow. So waste sector has to assume these responsibilities. Now, from the consumer's perspective, and what where consumer has to take responsibilities, partake in a new consumption model. So whatever new models we are talking about, consumers need to adopt that. If we are still in the rat race of owning each and every new thing, then it creates a lot of waste. It basically fails the purpose of circular economy. So the model which we were discussing earlier, that like rent, lease, or the pay-per-use, those models, if are widely accepted, that helps in minimizing the waste. Then accept new product aesthetics and materials, increase reuse and repair of products, and waste sorting at the household. So definitely few pointers in this consumer side we are already doing, but there are few others where we as a consumer need to adapt and move ahead in support to support the circular economy concepts. Now, circular economy as an opportunities and challenges. So definitely we all can see from its definition and its so far discussion that it presents a lot of opportunities, and basically it helps us in reducing the pressures on the environment. It enhances the security of supply of raw materials. It increases the competitiveness when we are whenever we are producing a material or the product. It actually increases the competitiveness. It promotes innovation, because the way you're going to design your product, the innovative strategies or technology you're going to use, the more better product and its utilization would take place. Strengthen economic growth and create new jobs. Definitely when we are going to adapt new technology and processes, the requirement for the new jobs or similar skill set will take place, and that gives a market a good push. Challenges with the CE implementation would be that it has considerable transition costs, and key economic enablers need to be taken care. Missing technical skills, because the new technology which we are talking about, the adoption skills, the time it needs, there is a gap in terms of the technical skills there. So that need to be taken care to implement the circular economy principles at a larger scale. Consumer behavior and business models, we have discussed this part earlier in earlier slides. So consumers has to adapt to the new ways, and so same way businesses also need to adapt those new business models, where they are effectively utilizing the design and similar processes to make their product which are aligned to the circular economy principles. Taking actions on multiple level of governance. So that is a point related to the regulatory or the policy framework which we discussed in the just one slide earlier. Now, circular energy transition is summary of basically facts and learnings for energy sector. So based on multiple reports and multiple write-ups which has been presented so far in this field, a quick summary of those pointers through a report I'm presenting here. So there are key 3 points which has been pointed out in that report. So basically, first one is the exponential demand of critical materials driven by the energy transition may trigger supply chain problems. Why it is so? Because the transition to renewable energy, it is having a major shift from the fuel intensive power projects, right? So when we are moving through that line, we are in need of multiple critical materials for, suppose for example, lithium ion batteries, right? So and solar panels. So those require a lot of material, and mining processes take place for that. And once we are transitioning on those lines, we have to think through the part of it, like the end of those life of the photovoltaic cells, panels, or the lithium ion batteries. What would happen to that? So in that transition process, we are creating a lot of waste, which and in fact the report says that from 2030 onwards, the renewable energy sector will face a tsunami of waste, because those PV panels, the turbines, the lithium ion batteries will be coming at the end of the life. So from the circular economy perspective, we have to think through those lines also, so that at least we are able to find right approach to utilize that waste going forward, because we still have our time in our hand. And so far we have to work on those lines as well, so that we are not contributing to the waste even by utilizing using the renewable energy sources. Second is circular economy business models could help decouple the renewable energy sector from the material consumption. So how it could be done? So basically, to reduce the overall demand for critical raw materials and minimize supply risk, we have to in the renewable energy sector, basically it has to transition towards a circular economy. As I was, it is a kind of an extension of the point number one, which I was explaining, because unless the circular economy does not take place, even if we are using the renewable energy sources, we are going to create a lot of waste. It's just that the method has changed, but the waste would be more or less same. So that's where the circular economy concepts will come in picture. And how we can do that is that we have to circulate equipment and materials, rethink business models, and rethink material choices. So such a framework actually can unlock economic opportunities by creating, and it can also create extra jobs. Those all aspects would be definitely coming as a plus with adoption of the circular economy principles. Third one is facing major economic and regulatory financial barriers. The transition of the sector towards the circular economy still has a long way to go. Definitely, because so far we are not having any policy or any clear policy or clear directions set out by the government regarding the recycling of solar panels, wind turbines, or lithium-ion batteries, and which does not even, we have yet to allow the recovery of most critical materials also. And then lithium-ion batteries and PV panels are designed for durability, not to be repaired or refurbished. Prices of second-hand PV panels are not competitive. Administrative requirements hinder the wind turbines' life extension. Investing in recycling infrastructure remains risky and not always economically attractive. So rather, basically, if we look through the lenses of circular economy, the policy framework, the subsidies should not only flow on the generation or the distribution side of any products or materials or the services. It also has to look through the waste which is going to be created throughout the process, or after the process, what we are going to do with that waste, and how we can look at the policy, how we can take policy measures so that we can also address the problem of that waste through the circular economy. Now, what could be the action plan for the industry, policymaker, and the investors on the circular energy transition? So, obviously, since we are talking about implementation of the circular economy, a right action plan need to be prepared and implemented. It is not a single plan, but yes, it could constitute multiple such values which would be common to us. And then this would again keep on integrating as the challenges may arrive and as the technologies, as the solutions, as the strategies and the ideas would keep on evolving. So still the basic action and key principles which still remain for which form the base for such strategies or the ideas would be that design assets for a circular economy. Whatever assets or whatever products we are designing, that need to be designed keeping the circular economy or circular transition in the focus. Second is build circular value chains, and third is create the right economic and policy conditions. So these three things will definitely, as a guiding principles, could help us achieve circular economy in our operations, in our production, in our implementation as well. So design of assets for a circular economy has design of assets for a circular economy have key 4 pointers. Like industry players should consider life extension strategies at the design stage so that those products are better utilized. Second is investors should require manufacturers to design assets for the circular economy. If investors are pushing for such products, definitely the industry players would be willing to do so. Third is policymakers should fund research and development on the design for recycling to decrease the recycling costs. So if policy makers are pushing through these lines, that will definitely shape in a right way. Fourth is industry players should set international design standards within the battery industry with the support of policymakers to increase batteries maintenance, repair, and repurposing. Coming to second point, build circular value chains. How we can do that? What are the key pointers which support it? So industry players should build cross-sector partnerships and alliances at the scale of secure critical material supply. So once we are communicating across the sectors and partnerships are taking place, that would help us give more visibility and more ideas could be exchanged, more experiences could be shared, which would be helpful in designing the processes and then implement the circular economy. Policymakers should incentivize the creation of joint ventures and partnerships through regulation to ensure the sustainability and competitiveness across the value chains. Another is policymakers should promote the exchange of data among key stakeholders for all renewable equipment through the introduction of the product passports. So basically, product passport is a concept basically where we have to give an identity to a product and its category. And if multiple similar products are in place across the globe, they could be categorized or defined in a similar manner, and their technology, I mean, keeping the IP part aside or keeping that secure, the ideas could be discussed from the circular economy perspective. Next one is the industry players should establish a quality standard and second-hand photovoltaic panels as well as the LI batteries and wind turbine equipment and components. Going to the last one, create the right economic and policy conditions. So from policymakers' perspective, what implementations or what steps they need to take is or suggested are policymakers should introduce extended producer responsibility APR measure for the entire renewable energy sector to ensure dedicated and sufficient funding for the treatment of the end-to-end equipment life. Policymakers should revise existing policies that slow the transition of the renewable energy sector to a circular economy. Investors should increase investments in the growing battery recycling market and the emerging photovoltaic recycling market. Investors should rate investment portfolio based on circular economy principles, considering critical materials supply risk and the environmental impacts of the RE sector. Policymakers should fund research and development on recycling technologies, which we covered earlier also. So basically, the push has to come from the policymakers as well to set the tone right, to give the confidence to the producers and the consumers to act in the right direction, which is aligning with the circular economy principles. So with all these key pointers, what would be the respective recommendations for the industry, for the investors and the policymakers? So this is again a repetition of the earlier slides, but it is the segregation of those pointers which are specifically applicable to industry, investors, and policymakers. So those I have covered. So basically, industry should basically consider life extension strategies, set international design standards, build cross sector partnerships, and should establish a quality standard for for PV panels and batteries and all. Investors should basically require manufacturers to design assets for the circular economy part, rate investments portfolio based on the circular economy principles, and increase investments in the growing battery recycling where CE concepts are taking place. Policymakers should again, repetition of it is that policymakers should fund the research R&D activities related to CE, incentivize the creation of JVs and partnerships through such measures, promote the exchange of data among key stakeholders, revise existing policies so that the process is not slow, it is fast, it is taking a fast pace, basically to fast track the process of the CE transition, introduce EPR, and fund the R&D. So those are the key pointers which are specifically applicable to industry, investors, and policymakers, the three key stakeholders, major stakeholders which are falling under the CE transition. So with this, I end quickly my presentations, and I think I have been able to cover the topic within time. So over to you, Shayal, and so if there are any questions, I'm happy to take.
Thank you. Thank you so much, Mr. Vaishnav. Great presentation. So, any questions from our attendees? Now is the time for you to share it with us. Mr. Urfi he had to drop out since he had a meeting come in. But nevertheless, I would like to thank, I think it was a great session all in all. And for everybody watching us, while if you have any questions, I still give you 2 minutes while I conclude this session. Because with this, we come to the end of, the day one of our conference, which is the first edition of PowerGen ESG and Sustainability Summit and Awards 2023. Tomorrow we start our day at 10:30 a.m. 10:30 a.m. Again, it's going to be an interactive day like today with eminent industry experts. The sessions that are going to be discussed tomorrow would include renewable energy integration and future outlook, ESG reporting and metrics, financing ESG projects, and this will be followed by our much awaited awards, the CEE Sustainable Awards 2023. So do stay tuned with us tomorrow as well. And well, as I see no questions coming in, Mr. Vaishnav, I would say that your presentation was very elaborate and probably it has covered all the points. At times there are presentations where more to absorb, more to learn, and less to ask. So definitely this came across as one of them. Do share it with us. We would like to make it available for our attendees on the CE website as well. And once again, Mr. Vaishnav, thank you so much for your time today. And we will look forward to having you join us tomorrow as well.
Sure. Thank you so much, Shayal, and thank you so much, CE team and all the attendees for taking out time to listen to this presentation. And in case you feel, please feel free to reach out in case you have any questions. I can take them offline as well. So thank you so much once again for the opportunity.
Thank you, and have a great day. Thank you, everybody. I shall take your leave here, and here's wishing you a great evening ahead, and we will see you tomorrow. Thank you and good evening. Bye.